would it be rounded up to 27 grams or 27 moles?
We don't even need to round it yet.
Okay.
Right. But yeah, it's 26.98 according to mine, which is, of course, also just rounded. And that's grams per mole. Right. When I show that to you, is it backwards? Okay, good, because it's backwards for me. But for you guys, I'm glad you've seen it. All right. And what's the molar mass for fluorine? Michael, what's the molar mass of fluorine?
Sorry, I'm not. It would be the mass of fluorine, so like 18.9 times the that mole unit. Is that right?
No, it really is just that 18.9, or mine says 19.00 grams per mole, right? So we're talking about a molar mass. We're just asking how much does 1 mole of that thing weigh, right? So here, go ahead.
No, sorry. You're fine.
No, so we know that aluminum has a molar mass of the 26.98 grams per mole. And the fluorine has a molar mass of 19.00 grams per mole. But the question is, how much does 1 mole of aluminum fluoride weigh? Right? So we're going to have to figure that one out using the molar masses of aluminum and fluorine. Right? So how are we going to do that? And how are we going to use the chemical formula ALF3 to answer that question?
Wait, wouldn't you just do the AL, which would be 26.98 plus F times, like you have 3 Fs, you have 18.998. You times that by 3, and then you add the AL, which is 26.98.
Yeah.
That
exactly
would
Noah.
Very good. So we're going to do that. Hopefully everybody has their calculators with them. Does anybody not understand why Noah said we need to multiply it by 3?
Why 3?
Because you have 3. Here you've got 3 atoms of fluorine in every molecule of aluminum fluoride.
Oh, yeah.
Does that make sense?
Mm-hmm.
Okay. And now we're just going to use our handy dandy calculators. And I get 86.98. And what's the unit on that?
Grams per mole.
Good. Grams per mole. Okay. So this is what we call a formula mass, right? The formula mass is the mass of 1 mole of a chemical formula, or the formula weight. Yes, Emily.
So is that the mass, or is 84 grams per mole the mass?
Oh, good question. I think I must have made a typo. So, good catch. I wonder why I made that mistake. It's not going to make a huge difference in our answer, but did I make a mistake when I calculated 86.98? Is that what you guys got? 87 or is it 84? Check my
I
math.
got 84.
You got 84? Yeah. I've keyed something in wrong. All right. Thank you very much, Emily. All right. There we go. Now I've corrected that. Everybody following along? If I did something wrong, shout it out. And if you don't understand how I got something, shout that out too. Okay? All right. So now to our original question then of how many moles of aluminum fluoride are in 1 kilogram of aluminum fluoride. Right? So we know that 1 kilogram of aluminum fluoride is how many grams of aluminum fluoride?
1,000.
Good. It's 1,000. All right. So we've got 1,000 grams of aluminum fluoride there. Now, how do we convert that to moles? Yes, Emily.
Would you divide it by 84.0 grams per mole to
Let's try it.
figure out moles? Or wait, yeah.
Right? So Emily's asking, can I do this? Well, let's try it. Right? 1,000 grams of aluminum fluoride divided by 84.0 grams per mole of aluminum fluoride. Plug that again into my handy dandy calculator. Right? I plug this into my calculator and I get 11.9. Did I do that correctly? Okay. So now the question then is, what's my unit? Right? Remember, let's get out of the habit of asking the question, what unit do I want to be there? And ask what unit is actually there. And so we have grams on top and grams per mole on the bottom. Right? So the grams cancel. The mole, right, in our per mole, our inverse moles here, then become on top. Is anybody having trouble with those? I know that fractions oftentimes trip people up. And so if you have questions about how we work that through, then please let me know. Yeah, Emily.
So then would you just divide 11.9 times by 2 to get the moles
Crazy
of
reliable. More
aluminum
reliable.
oxide,
It's
and then
reliable.
multiply
People
that
hate it.
by 102 grams per mole to figure out the mass?
Well, that sounds right, but let's check it. We got to use our chemical equation here, right? And so we know that we're trying to figure out how much mass of the aluminum oxide we need. But in order to figure out the mass of the aluminum oxide, we need to figure out the number of moles of aluminum oxide, right? So what's the ratio here between moles of aluminum fluoride and moles of aluminum oxide?
1 mole of aluminum oxide equals 2 of aluminum fluoride.
Yes. Right?
Mom. I got it all wrong. Yeah. No, it's mute. Mom, it is so much harder than I thought it was.
Right. So everybody see this,
Yeah.
right? And this ratio here is coming directly from our balanced chemical equation, right? It has to be balanced in order to get the proper coefficients. All right. So check and make sure that your units work.
Tell him that he's going to end up with high blood pressure. Tell him you're going to tell my mom said.
But I've got
40 years old with your cheeks all ready, your belly out, and high blood pressure. Don't marry him.
Is this what you guys got?
He's going to die of a heart attack early.
5.95 moles of aluminum oxide. Does that sound right? All right. But the question isn't how many moles of aluminum oxide we get. The question is instead how many kilograms.
Okay.
So we just need to take that number
No, it works.
and translate it into
Helium, lithium,
a mass.
beryllium. I've never done this.
And to do that, we're going to use the molar mass of aluminum oxide, which fortunately
That makes sense.
has been given to us.
Yep. So if we have that tall guy who's dark skinned, Judah,
Okay,
he has a
I'm on
Simeon,
this. Yeah.
blah, 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 blah.
So I've got something that looks like that. Anybody have questions about that?
So are you multiplying 5.95 moles of aluminum oxyfluoride, or what is that?
Aluminum oxide.
Aluminum oxide times 102 grams of aluminum oxide.
There's a balloon that's hanging
Not just the grams of aluminum oxide, per mole of aluminum oxide.
Ooh, okay.
Right.
So grams
This
per
way
mole.
my units are going to cancel, and I'll be left with grams of aluminum oxide.
Okay, cool.
Good
Thank you.
question. All right, so let's calculate that.
Be really yum or barely yum. Someone on the table. I know, but I'm too beryllium out of 4 out of 30 or 40.
Every time I use the sentence with my teacher in Spanish, or instead of hola, hello, how are you?
Yeah.
She answers back, and I answer back to her, so we answer her.
Nice. Say next time. Say curious. What time is it? Yeah. Ha! I got a finger.
All right. Anna, what'd you get?
I'm just kind of lost. I kind of got lost at the 11 point.
At the 11.9?
Mm-hmm.
Good. That's very helpful to know where you got lost, right? So that we can find where we ultimately want to go.
Yeah.
Right. So, with the 11.9 moles of aluminum fluoride.
Mm-hmm. How did you get that?
Okay. So we started off knowing that we have 1 kilogram of aluminum fluoride.
Mm-hmm.
And then we translated that to 1,000 grams of aluminum fluoride, because 1 gram of anything is always 1,000 grams of that same thing. Does that make sense?
Yeah.
Okay. So that's just definitional. Now, in order to figure out, we have to translate somehow the mass of it into its number, into its count, right? So we want a unit of count. And moles are always going to be the most helpful to us in a chemistry class. So otherwise the numbers are just way too big for us to deal with. So I know that 1 mole of aluminum fluoride weighs 84.0 grams.
Okay.
Okay. Did you follow how we calculated that?
Yeah, I got that.
Okay, good. So if we take the mass
Hmm.
and we divide it by the molar mass, then that's always going to give us the number of moles.
Okay. So you do
Right.
like you have 1,000 divided by
What's that? I'm sorry?
it. So do you do 1,000 divided by 84?
Yep.
Okay.
And then did you get 11.9?
Yeah.
Okay, good. So then, right, another way of thinking about that, right, is just if I have, I don't know, 2,000 pounds of basketballs, right, a ton of basketballs. How many basketballs is that? I don't know. How much does a basketball weigh? But if you take that 2,000 pounds, you divide it by the weight of one basketball, it tells you how many basketballs there are. Okay? So this tells us how many moles of aluminum fluoride there are.
Okay.
All right. So then, knowing how many moles of aluminum, or of, in this case, aluminum fluoride, we can then use that to tell us how many moles of aluminum oxide we have. Do you follow that step?
Yeah, I think so.
Good. Okay. Where do I get this 2-to-1 ratio here?
Like the conversion crossed out.
So I think this is one of the things that we're missing. Is this 2-to-1 ratio is coming from our balanced chemical equation.
Oh, okay.
Right?
Yeah.
So we're just using the coefficients here. 1 mole of aluminum oxide produces 2 moles of aluminum fluoride. Does that make sense?
Yeah, I got that.
Okay, cool. All right.
Okay, so once you do that, you get the 5.95 of not grams per mole.
Well, at this point now we have 5.95 what? Looking at our chemical equation here.
Mole for aluminum. All right.
Or we have 5.95 moles
Yeah.
of aluminum oxide.
Hmm.
But the question doesn't ask for how many moles of aluminum oxide. It asks for how many kilograms of aluminum oxide.
Yeah.
Right? So we're going to have to do a similar conversion. Right? When we started with the mass of aluminum fluoride, we could figure out how many moles of aluminum fluoride.
Mm-hmm.
Basically, we're going the opposite direction now. But it's the same thing, just reversed. Right? Here we have moles, and we want to get to grams.
Okay.
Okay?
Okay. Yeah, I think
All right.
Thank you.
You're welcome. All right. So when we plug those into the calculator, did everybody get something kind of like this? 607 grams of aluminum oxide. All right. And then ultimately, of course, the question asks how many kilograms. So we'll just do a quick conversion. 607 grams is 0.607 kilograms, right? We just move that decimal place over 3.
Is it okay if we left it so 0.6069 kilograms, or do we need to just have 366?
Technically, you should only have 3 because that's all that you have in the mass of the aluminum fluoride.
Okay.
But I'm not trying to be super picky about precision right now? Yeah, that's a good question. All right. I can't even remember whose question that was originally. Emily, does that answer that question? Okay. Now, given that, are there other questions about the homework?
Could you put that board up again?
Yeah. Let me see. Which one? This one? Or the homework?
Yeah, that one.
Yeah. Let me see if I can get it all in there.
Okay. I took a picture, so unless anybody else needs it, I'm good.
All right.
Can we go over the last page?
Yeah.
Yeah.
Okay. And this is good. I think that this is going to be the most helpful for that lab. And ultimately, this one is a question about, I wanted to hear, this is sort of that rhetoric, right? The logic that we've been using to translate the molar masses to the actual masses to the number of moles of things is really logic. Can I get from one thing to the other? This question is more a question of rhetoric, which is, how do I use that logic to make a case? And the case here is asking a question of what material is formed when we burn magnesium, right? So if we have a chance in the lab, this is something that we can do. We can just take magnesium ribbon and we can heat it in the presence of oxygen, and it will combine with oxygen to form a white solid, right? And then the question is, well, what is that white solid? Is it Mg2O? Is it MgO? Or is it MgO2? Right? We can use chemistry tricks to kind of figure that out. But so this is a good question to ask early on when you haven't learned those tricks, right? So here I have equations A, B, and C. Does everybody see those? Which one's A, which one's B, and which one's C? Okay, I don't know if you guys had seen that convention before, but that's a pretty typical way of doing things, and I'll keep using it. So if magnesium oxide is MgO or Mg2O, then the chemical equation for its formation is given by A. If magnesium oxide, that white powder that's formed, is MgO, then B is describing its formation. Or if it's MgO2, then C describes its formation. Does everybody understand what I'm showing in those chemical equations? Okay. And I can't see all of you at once, so if you don't see, go ahead and just speak up. Unmute yourself and speak up. All right. So then the question becomes, how do we know which one is right? Right? I've given you 3 equations. All of them are balanced. But only one of them describes what really happens in the lab, what really happens in nature. And we'll talk about in the future why only one of these things happens. It's not all 3. But only one of them actually happens. And so we want to ask the question of, well, which one does happen before we try and explain why? And so question number 8 is really asking, if you have lab data, right? All of these questions are based on this lab data, right? A team of students placed 12.4 grams of magnesium in a crucible and heated it up, right? Basically, they let one of these reactions happen. The question is, which reaction happened? So take a look at number 8, and it says, how much magnesium oxide would form if 2.4 grams of magnesium were fully reacted with oxygen to produce Mg2O, right? Start with your chemical equation. That's always a great place to start. So here I've told you we're going to use equation A, right? So we have the combination of 4 atoms of magnesium metal with 2 molecules of oxygen gas to produce 2, what we call formula units. You can talk about that a little bit, of magnesium oxide, right? Yes, Emily.
Sorry, I was trying to get my mic. So do you have to convert 12.4 grams into moles then?
Yeah, absolutely. That's exactly where we want to start, right? So go ahead and do that. And then hold your picture up to the camera for me so I can see what's going on.
Wait, what are we doing?
Okay. You're going to convert 2.4 grams of magnesium into moles of magnesium.
Is it 2.4 or 12.4?
I'm sorry, 12.4.
Oh.
And if you think you can answer this without your periodic table, you're wrong. So if you're using your periodic table, then you must be right.
Is the atomic mass the same as the weight of 1 mole?
Yes. Yep.
Okay, thanks. You want us to hold it up?
Yes, please. All right. Everybody else keep working. If you have trouble, let me know. Thanks, Emily. I've got yours.
So, Mr.
It's supposed to
Lolovich,
be a really big number.
What's up, Jesse?
I'm sorry. So in order to figure out how much magnesium oxide would form, would you be multiplying how much one atom of magnesium, how many moles of magnesium, you would multiply it by 12.4 grams? Would you be multiplying or dividing?
See, that's an important question, right? And the units are going to answer it for me, right? So here are 3 different ways to sort of visualize this problem, right? You can think of it in terms of a unit conversion, right? Where I know the relationship between 1 mole of magnesium and grams of magnesium, which in this case is 24.31 from my periodic table. Another way of thinking of it is dividing, right? I can divide the mass of the magnesium by the molar mass of the magnesium. Or another way to represent the units here I don't know if you guys are more comfortable with this. I don't love having fractions in the denominator. That always gets a little bit funky for me. So sometimes I like to use inverses. So if you're familiar and comfortable with this, use it. If not, you can use this or this, whatever feels good for you. All right. This is 3 ways of answering the same problem. All right. Thank you, Noah. You're welcome. Does that make sense, Jesse?
Yeah, much more sense. Thank you.
Okay. All right. All right. So as I've calculated it there, I get the same thing each time. Does anybody have questions about how I calculated that?
Okay, I have a question because I got a completely different answer.
Okay. What'd you end up getting?
I got 24.305 grams to mole.
Okay, 24.305 grams per mole.
Yeah.
Did you get that from your periodic table?
Yeah, I did. And I don't know how I got that again. That's why.
Okay. So I'm using that same value. I just need to know. I just have a different rounding on mine, right? Because my periodic table just gives me 2 digits, right? But I'm using that molar mass to translate the measured mass of magnesium. Right? So you're sitting in a lab. I can't count atoms. I can't count moles. Right? So instead, what I'm doing is I'm using a mass that I can actually measure in the lab, which is 12.4 grams of magnesium. Then I can divide that by the molar mass of magnesium. And that'll tell me how many moles of magnesium I have left over. Does that make sense, Noah?
I'm getting there.
Okay, that's all right. This is practice. All right. So, this is the number we want to take forward with us, right? Because this doesn't answer the question. It's just an intermediate step. It tells us how many moles of magnesium we started off with, right? And so we have to somehow translate that into moles of magnesium oxide, right? And so we're going to be doing that using our balanced chemical equation, which is equation A. Garrison, I can't tell if you're looking confused or if you're just following along.
Yeah, I am a little lost. So, why would you divide that and not use proportions with Avogadro's number or whatever it is?
Okay, that's a great question. Why would I not use Avogadro's number? Because I can't count atoms. I just can't. So I only need Avogadro's number when I am counting individual atoms. Otherwise, I don't need it. I'm going to do everything in terms of moles. Another way of putting it is this way, right? If a dozen eggs cost $2, how much does 4 dozen eggs cost?
My internet died like halfway through that sentence. Can you say it one more time?
If 1 dozen eggs costs $2. How much does 4 dozen eggs cost?
$8.
Right, $8. Why didn't you need to multiply anything by 12?
Because that's not what we're talking about. It was
Exactly.
money.
That's exactly right. It's the same thing when we're doing our chemical reactions, right? We are only dealing with moles, so we can just stay in moles and we don't have to worry about anything else. Okay?
Okay.
All right. So here, we then somehow have to translate the moles of magnesium we started with to predict the mass of the magnesium oxide that we end with. And we can't just do that in one step. We need 2 different steps to do it. So we need to first figure out how many moles we react or we produce, right? So right, I can use my chemical equation to give me a pretty straightforward translation, right? We're going from moles of magnesium into moles of magnesium oxide. Does that part make sense, Dan?
Wait, I have a question.
Yeah.
How would you figure out the 2 mole Mg2O and the 4 over 4 mole Mg?
Great question. Directly from my chemical reaction. Okay, so this is the balanced chemical equation relates 4 moles of magnesium to produce 2 moles of magnesium oxide. And so those things are equivalent here. And that's where I get this ratio.
And why wouldn't you want to do the 4 on the top and not on the bottom?
That's a great question. If I did that, let's look at our units, okay? Okay. So the question is, do I want to multiply it by 2 over 4, or do I want to multiply it by 4 over 2, right? And I don't always know, right? So I'm going to go through and I'll do both, and we'll figure out what units are left over, all right?
I get it.
Okay, so here, moles of Mg cancels with moles of Mg, and the only thing that's left is moles of Mg2O. If we use this, what cancels? Well, really nothing cancels, right? Because this is a mole of Mg, and this is a mole of Mg2O. So that's not the same thing. So those can't cancel. So we'd be left with moles of Mg squared, right? Moles of Mg times moles of Mg divided by moles of Mg2O. That's why I think it's good to be really explicit with our units and not just leave it as moles, Because if you just leave it as moles and you don't specify this moles of Mg, then you might think that they would cross out and you'd be left with an answer that's incorrect. That's why the units are so helpful in chemistry. They can help you from keep you from making those mistakes. But that's just a way of seeing that ultimately we know that we're going to produce half as many moles of Mg2O, not twice as many moles. Okay? All right. So what do we actually end up with when we do it this way? All right. Did you guys get something like that? All right. Any questions about that step of it? All right. We always want to go back to the original question, which is using this chemical equation, predict how much magnesium oxide would form if 12.4 grams of magnesium were fully reacted. So you could leave it like this, right? How much can be answered with moles? It could also be answered with mass, right? So let's go ahead and convert these 0.255 moles of magnesium oxide, Mg2O, convert that to a mass. Go ahead and do that now.
Wait, if you multiplied it by 4/2, you're just multiplying it by 2. So why did you get like 0.25 whatever?
Well, let's take a look. Right, you're asking basically why did I get 0.25 rather than 1?
Oh, so you did multiply by that top one, the 2/4.
Yeah, and I know okay. That's the right way to do it because of the units.
Yeah. Okay, sorry. I thought you were saying you did it by... Yeah, never mind. Sorry.
No, good question. No, that's a great question.
Mr. Lillivigan?
Yes.
Jesse's computer died, so.
Okay.
I was able to get back on, Mr. Lillivigan.
I see you there. Thanks.
Oh, never mind.
All right. I want to go ahead and we're coming up on an hour here. I want to answer this question all the way through. And then I think that will probably give people enough information that they can go and finish up any problems they had with the homework and start on the homework for Tuesday. If you have more questions, then just stay on and ask questions. But if you are good after we've answered this problem, then you're free to go. Okay? Does anybody have questions now about what the homework is for Thursday?
What is it?
It's there's a worksheet posted in Google Classroom. I think it's called sulfur hexafluoride worksheet.
Do you want us to turn this worksheet in online, or do you want it on Thursday?
Um, the homework that's due today, you're asking
Yeah.
about?
Yeah.
Go ahead and turn that in online.
Okay.
Right. So we got to find our molar mass. See if we can figure that out. Vito, do you have that answer?
Not yet. I'm just trying to figure out because I know I need to put the for units on the bottom needs to be moles of magnesium oxide, but I just don't know how to get that.
Good. So you're going to do it using the molar mass of magnesium oxide. Right. Did anybody else? Can anybody check me on that one? 64 point.
Yeah, I got that.
Okay.
Could you show the board again?
Yes. That one there?
Yeah.
So that's
Thank you.
just calculating the molar mass.
Right. I just don't understand how you got that.
How I got, okay. How I got this
Well,
number
I
here?
understand I understand the top part, but I don't understand why you got like the 16.
Okay. That's the molar mass of oxygen.
Okay. Yes, I understand now.
Okay, good.
And is it 64.62?
I think so. Yep, that's what I got.
Okay. Thank you.
You are welcome.
That makes so much more sense.
Excuse me.
And then once you get both the 0.255 and the 64.62, do you multiply them together?
That's a great question. What units do you get when you multiply them together?
Moles or grams?
Is that what you get or what you want to get?
That's what you want to get.
Okay, so is that what you actually get when you multiply them together?
No. So you want to divide them.
Check your units.
Okay.
Yeah, Emily.
Would the answer to the second one be 20.3 grams, or did I do that wrong?
I think you're off on that one, but let's check. Check my math, all right? Jesse, take a look at this one too. So if I take my 0.255 moles of Mg2O
Mm-hmm.
and I multiply that by my molar mass, then I got 16.5. Let me check my units here. No.
I got
didn't get on here.
16.5 on number 8, but on number 9, is it 20.3?
That sounds about right. Yep.
Okay, cool.
Yeah. Sorry. So, Jesse, if I check my units, then the moles of Mg2O cancel.